October 7th, 2025. Every telescope from Earth to Mars is aimed at a single target, 3I Atlas, the interstellar comet that was supposed to give humanity its first clear look at a visitor born beyond the sun. Yet, as the countdown to its closest pass hits zero, every major observatory begins to fail in the same way. Cameras glitch, data links freeze, Mars orbiters that should be streaming high-resolution frames return nothing but static. And then, silence. For hours, the only image that reaches the public is a blurred speck, a single pixel too faint to prove anything, too bright to ignore. Within minutes, it becomes the most analyzed dot in history. Theories explode across NASA feeds and amateur networks. Was it interference, a sensor overload, or something that simply refused to be captured? The mystery deepens when other agencies confirm their own losses. Identical transmission dropouts, synchronized to the second. Suddenly, the question shifts from, what is it, to, why can't we see it? This is not just another deep space discovery. It's the first time a celestial object has fought back against observation. In the months before that moment, 3I Atlas had already refused to play by the rules. It wasn't discovered by a professional observatory, but by an automated asteroid survey that flagged its impossible trajectory. A hyperbolic path, slicing straight through the inner solar system. From the beginning, its brightness curve made no sense. It flared too soon, dimmed too quickly, and reflected light as if made of polished metal, not ice. Astronomers at the European Southern Observatory compared its spectrum to known comets and found something missing, the signature water bands that define every frozen traveler we've ever seen. Instead, Atlas showed traces of carbon dioxide and silicates without the usual dust halo. It behaved less like a comet and more like an object built to look like one. At first, scientists blamed calibration errors. But when cross-checked with data from NASA's NEOWISE and China's Purple Mountain Observatory, the same anomaly repeated, a reflection pattern sharper than any natural surface should allow. The numbers didn't line up, and neither did the timing. Each time it neared the sun, its tail rotated at a perfect 90-degree interval, as if it were responding, not reacting, to solar pressure. Something about 3I Atlas didn't fit any model of how comets should move, shine, or die. By early October, the data war had already begun. The European Space Agency's Trace Gas Orbiter detected bursts of carbon dioxide so pure they defied normal comet chemistry. Meanwhile, NASA's Deep Space Network logged weak but rhythmic radio pulses near 1.4 gigahertz, the hydrogen line, the same frequency used by SETI to listen for artificial signals. For 2 days, the pulses repeated, then vanished without trace. Dr. Mallory LaFranc from the University of Arizona argued it was solar interference, yet her own paper admitted the pattern was unexpectedly coherent. Others went further. A small research team from Kyoto suggested the emissions matched modulated spin intervals, not random outgassing. At the same time, orbital mechanics experts noticed something subtler. Atlas's path shifted by fractions of a degree after each solar pass, far too consistent for random jets of vapor. When plotted across several weeks, the deviations formed a geometric curve, a pattern almost intentional. ESA engineers tried to model the shape using standard non-gravitational forces. Every simulation failed unless they introduced a variable thrust, as if the object itself could control how much material it expelled. NASA spokesperson dismissed the notion as coincidence, calling it a computational artifact. But in private forums, astrophysicists traded the same uneasy phrase, controlled stability. By now, what started as an interstellar curiosity had turned into a riddle that neither physics nor probability could comfortably explain. October 7th, 2025, the closest flyby. Mars, 30 million miles from the comet's projected path, becomes the center of humanity's observation grid. Every orbiter, lander, and telescope is programmed to capture the moment. For planetary scientists, it's the ultimate test, whether we can truly study an interstellar visitor up close. But hours before the pass, a wave of quiet spreads across mission control rooms. The American government shutdown halts NASA's high-rise operations aboard the Mars Reconnaissance Orbiter. No new commands, no uploads, Every scheduled image capture freezes in queue. At the same time, ESA's ExoMars camera reports bandwidth instability, while China's Tianwen and the UAE's Hope orbiter quietly drop offline without explanation. To the public, it looks like coincidence. To those watching the raw telemetry, it feels orchestrated. 4 independent data streams, 4 blackouts, within the same 5-minute window. The only functioning eye left is the Perseverance rover. Its navigation cameras are ordered to scan the sky above Jezero crater for 10 straight minutes, capturing a faint streak, a line of light too sharp to be a glitch, too aligned to be random. When the frames are stacked, the direction points almost exactly toward the predicted trajectory of 3I Atlas. If confirmed, this would be the first interstellar object ever recorded from the surface of another planet. Yet the data remains sealed, pending verification. For scientists, tonight isn't just another observation window. It's a stress test for the truth: who controls it, who filters it, and who decides what the world gets to see. As dawn broke over mission control, analysts divided the mystery into 3 possible outcomes, each more unsettling than the last. The first scenario, the safe one, says 3I Atlas is simply a comet at the edge of detectability. Its erratic reflections and faint radio noise could come from complex surface geometry, maybe shards of nickel-rich ice catching sunlight at strange angles. Under this view, the silence from NASA, ESA, and others isn't conspiracy but caution. The raw data is too messy to release before it's verified. The second scenario ventures closer to danger. What if the object is shedding fragments or venting jets of gas powerful enough to alter its path? A debris field at 90 kilometers per second could devastate a Mars orbiter. The sudden blackouts in this case might have been emergency safeties, automatic shutdowns to protect sensors from high-energy particles or dust impact. It would explain the synchronized silence, but not the rhythmic hydrogen line pulses that preceded it. Then comes the third scenario, the extreme one, the one no one dares to voice in public briefings. Some astrophysicists whisper that the object's trajectory corrections resemble navigation, not random jets, but deliberate course changes, timed to maintain a fixed geometry with Mars and Earth. The hydrogen line signal, repeating every 72 seconds before vanishing, mirrors the pattern of the historic WOW signal from 1977. If this holds, 3I Atlas might not be just passing through space. It could be responding to something, or someone. Even before the comet vanished behind the sun, the implications had already rippled through science communities. If 3I Atlas was natural, its anomalies would force a rewrite of cometary physics, new models for sublimation, reflection, and non-gravitational thrust. But if even one of the controlled behaviors proved intentional, humanity would face a question it is never truly prepared to answer. What if we just witnessed technology operating beyond the solar system? At NASA's Jet Propulsion Laboratory, engineers debated whether to release their partial radar telemetry, which showed brief spikes of coherent backscatter, something that could mean either reflective metal or a mirage of ionized gas. The data could confirm extraordinary structure or destroy reputations if proven wrong. At ESA, the same tension spread: open transparency or institutional caution. For the first time since the Oumuamua debate, scientists feared their own words could fuel conspiracy rather than knowledge. Beyond the labs, the political layer emerged. If one nation's spacecraft captured undeniable proof, would they share it freely? Or would it become classified, a matter of national security rather than scientific discovery? In the United States, congressional aides began drafting clauses about extraterrestrial data governance. The debate extended into philosophy. What if the universe is full of intelligence, but our instruments simply aren't welcome to look? Would we still call ourselves explorers, or just trespassers? For every signal lost, a deeper question rose. Are we facing the limits of our technology, or the boundaries of permission itself? While governments argued and observatories went silent, a different kind of network stayed awake. Amateur astronomers, the silent backbone of discovery, turned their rooftops into data stations. Across Arizona, Kyoto, and Melbourne, dozens of small telescopes tracked the comet's last visible arc before it disappeared into solar glare. they shared raw frames on forums, synchronizing clocks down to the second, hoping that somewhere, someone might catch a glimpse the big agencies missed. Inside NASA's Jet Propulsion Laboratory, engineers rotated shifts through the shutdown, sleeping on cots beside idle terminals. One of them, an image specialist named Ethan Morales, stayed up 40 hours straight trying to reconstruct a missing telemetry burst from the Mars Reconnaissance Orbiter. "The signal's there," he wrote in an internal memo later leaked online, "but it's layered with something that shouldn't exist, a pattern that looks like echo." In Europe, the ESA ground team in Darmstadt did the same, hand-verifying every packet from the ExoMars orbiter. "It's not about mystery," said Flight Director Helene Bourget. "It's about making sure the universe is what it says it is." Her quote trended for a day, then was buried beneath speculation threads and fake images. Each of them, scientists, students, backyard skywatchers, kept the vigil not because they expected an answer, but because they couldn't stand not knowing. When the data finally clears, it will bear their fingerprints. The sleepless nights, the recalibrated cameras, and the quiet conviction that truth in science is worth losing sleep over. As October faded into November, 3I Atlas slipped behind the sun and vanished from every telescope on Earth. For 40 hours, the sky itself became a blind spot. Then, on the morning of November 2nd, a faint reappearance, a flicker on ESA's solar monitor, confirmed that the visitor had survived perihelion. But its brightness was wrong again, dimmer than expected, as if it had changed shape or shed something before emerging back into the light. Scientists scrambled to fit new numbers into old models. None worked. The latest radar return hinted at a fractured core, but the signal-to-noise ratio was too low to trust. NASA promised a data release soon. ESA urged patience. The world waited. Yet beneath the numbers, a strange emotion settled in. Awe and something close to humility. For all our instruments and budgets, we had been outmaneuvered by a single traveler the size of a mountain, crossing interstellar space without warning and leaving us guessing in its wake. Maybe 3I Atlas was just rock and ice, sculpted by physics. Maybe it was something engineered, a vessel, a probe, or just debris from an older civilization. Either way, it reminded us of a truth older than science itself, that the universe does not owe us answers. Tonight, millions still watch the empty patch of sky where it once glowed, waiting, listening, wondering if, somewhere beyond the sun, it's still watching back.